This is the third lab for this course. We're going to be working with the net safety gas detection again. And this time we're going to be working with the Detronic system here as well. It's infrared point detection used for measuring combustibles. So we're going to be working with the combustible sensor over here now instead of the toxic sensor. So we're working with the two different systems and comparing them. So I've got similar equipment here that we used for the toxic gas sensor, the electrochemical cells lab. But this time around our calibration gas is different. We're using methane balanced with air. And you can see that the concentration of methane here is 2.5%, which is 50% of the LFL, lower flammable limit, or quite often the term we typically use in class and here in Canada is LEL, which stands for lower explosive limit. So this is going to be our calibration gas this time, a little bit different, but pretty well very similar procedures will apply. So when we go to calibrate or check, actually we're just going to be checking this system here. When we go to check this system, instead of using that calibration cup that we were using for the net safety system over here, we're just going to remove that calibration cup. You can see that I've removed it and just set it on the counter here. We're going to remove that, and then this tubing union right here, then it'll just thread right on to this piece of plastic tubing that's just hung here, so that we can introduce the gas into the point sensor. Right, so I'm gonna go ahead and wire up both the systems here for using the LEL sensor. There will likely be some questions on the wiring. You have to refer to the manual for that to answer those questions. Before I wire up the point watch Detronic sensor up here, the infrared sensor, I just wanted to point out here, you can see that it has the color-coded wires, just like the net safety system, the way that we've set it up. So the wires come out of here and they're color-coded just like this, and then these purple banana connectors run down to the conduit into the Detronic's housing here as well. So when you're looking up the wiring in the manual, if you need to refer to that, this is where it is on the trainer. All right, so you can see I've got power ran over to both units. I've got power ran over to the Infinity, the Detronic system here, and the Millennium 2, or the net safety right here, is powered up. The only thing you can see over here, we're reading about 1 right now, 1%, and you can see how it's in percent LFL instead of LEL, which is the same thing. And then over here, we've got a communication fault, and it's because the toxic gas sensors on channel 2. Channel 1 has the LEL sensor, the explosive gas sensor. So what we're going to do is we're going to make that change here. We need to disable this sensor because we're not using it anymore, and enable this one. So I'm going to bring up the main menu here, and I'm going to navigate down to enable, disable channels, and we want to enable channel 1. So press enter, and channel 1's enabled, and then we'll scroll down and we want to disable channel 2, and then we'll exit and go back and exit, and now you can see that our sensor is warming up. All right, so now I have channel 2 disabled and channel 1 enabled, but you can see that it's giving us this sensor zero drift, likely because the system hasn't been used in probably close to a year. The other thing that we wanted to have a peek at here is now it's been about 5 minutes or so, and you can see that this the Detronic system right here is reading 0. So everything looks good there. What I'm going to do now is I'm just going to apply some zero error here just to confirm and see if it doesn't clear our sensor zero drift, and then we're going to apply some calibration gas to see what that does here. But we may just have to calibrate it to get rid of this error. All right, so I applied 50% LEL to our sensor, and you can see here that it's reading 91%. So it definitely has drifted. I'm going to just go and throw the zero gas just on it one more time, just to have a peek, just to see if that gets rid of our zero error. But we'll see here, and I'll apply that the zero gas and see what it does. The air again, and it's dropping down, you can see, and we'll just see what it does once it hits close to 0. Oh, there, so it went back into sensor zero drift. So it must be, the range must have really expanded above and below the limits, or the calibration values, sorry. All right, so before we calibrate, we just want to enter the main menu here, and we want to go down and make sure that the gas type here is set for channel 1. We want to make sure that it is set for no correction. So there, I had to push the down arrow here, change it to no correction, and we'll push number 3 for enter, and there it should read no correction. Zero this, calibrate sensor, enter. We want to do sensor 1 now, and it's saying, do you want to calibrate the sensor? Click yes, and it's saying apply clean air, and so we'll click click 1, and it's setting the 0, and so we'll just wait for this to confirm the 0. So now it's saying apply 50%. All right, so now I'm applying 50% LEL, and we'll just wait to see. It should detect it. There you can see it's spanning, and the LEL is climbing. So once everything's stabilized here, then it should confirm calibration. All right, there we got the remove cal gas prompt, so we can now shut off our cal gas. All right, so I removed the calibration gas, and I added the 0 error, and you can see it's just coming down now to 0. It looks like the calibration worked. And yeah, it looks like it's going to hold steady at 0% LEL. So it looks like that fixed our problem. Just needed to be calibrated. The sensor had drifted. Okay, so one other thing that I'm going to have you look up in the manuals is a value here for, we're going into the main menu. And if we go down to select gas type, so under select gas type here, we're on channel 1. There's no correction being applied right now, but in the manual there's a table that tells us the correction factor to use. If the only calibration gas you have is methane gas like we have, we can actually calibrate this for other gases like propane or hydrogen or things like that. And so if we go into there, you can see that we can toggle this to a custom correction factor, and then we can change that value right there. So what I'm going to get you to do is to look up the value for hydrogen, and we're going to answer that in this lab. Now that the sensor's had plenty of warm-up time, you can see it's at 0. I'm going to go ahead and introduce calibration gas up here, and we're going to see how close, see if there's any calibration drift with this sensor. So I'll introduce that 2.5% methane right now, and we'll see. This should come up to 50% LFL or LEL. All right, so I'm just about to turn on the calibration gas. I just wanted to catch to see how fast this transmitter reacts. And just checking to make sure the flow rate is correct. There, we're pretty close. And look at that, the sensor hasn't been calibrated in over probably about a year. And it was quick to react, and it's stable at 50%. So it won't even need a calibration. So comparing this to the Millennium 2, which drifted quite a bit over the year, to the infrared system here, that is, looks like the calibration holds pretty good. All right, so if we did want to calibrate this Detronic system, I've removed the explosion-proof cover. You can see it fits right over top there. There's a little magnetic reed switch, and I'll just point that out to you right under here. It's this guy right here on the circuit board. It's kind of, yeah, right there on the bottom. You can see there's the wires. It's this bottom component on the circuit board, and it's basically sealed up. And when you wave a magnet over it, see if I can get this to focus a little better. When you wave a magnet over it, it closes two pieces. There's a set of contacts in there that close and you wave a magnet over it. So that's how we get it into calibration mode. And so I have right here, I've got a magnet. And so if I just wave this magnet under the bottom here, you can see that the screen there changes. And I think if you hold it for, we need to hold it for 9 seconds. And it should cycle into a, there, so it's doing a 0 cal right now. And then once it's done the 0 cal, it's going to ask us to apply gas. But since we're not doing the calibration, we're not going to bother with applying the gas. So there, after we've applied our zero gas for a little bit, now it's saying apply gas. So this is when we would apply our 50% LEL, and then it would calibrate to that. But like I said, since it doesn't need to be calibrated, I'm just going to power it down because I don't want to use up any of my calibration. So one last thing I wanted to showcase here is back over on the Net Safety Millennium 2 controller here. Right now it's reading 0 LEL. And what I've done is I've hooked up a multimeter here across the 4 to 20 milliamp signal, and you can see it's reading 4 milliamps, which it should, at 0% LEL. And I'll just show you where I've got that connected here over on our box here. You can see what I've basically added. We've got our power here. Let's jump it over to our Detronic system. And then I hooked my meter leads in here, the black going to the common, right there, to the common. And then the red is going to the 4 to 20 channel 1. So you can see we're on channel 1, reading 0. So that's good. What I'll do is I'll introduce a little gas, and we'll just see what it does. We'll just see if it reads correctly. Get it up to 50% LEL, and we'll check to see. This guy should be reading 50% span gas here. We're climbing, we're making our way up to 50% LEL. And if we look down here, our milliamps are getting up close to 12, which would be 50% between 4 and 20. And so at 48% LEL. We'll see if it gets up to 50. There we go, looks like we've hit 50% LEL. So 50% LEL, and we're reading pretty close to 12 milliamps here. It's kind of bouncing between 12 and, yeah, so we must be at 50% LEL, 51% LEL. So we're reading, looks like it's reading pretty close. Everything's good there. And so the next thing I wanted to show you is I'm going to take a reading off of channel 2 here and see what we get for. All right, so I moved my lead down here to channel 2. You can see the red lead, and we'll just have a quick look down here. You can see it's reading 2.52 milliamps. So what I'm going to get you to do, we're going to answer this question too. We're going to figure out what 2.52 milliamps means by looking up in the manual what 2.5 milliamps means when the controller is outputting that signal on that channel.